Assalamualaikum warahmatullahi wabarakatuh and hi, my name is Nawal binti Muhammad Radi with the metric number AA190201. So today my lab mate Sharifah Azila binti Roslan with the metric number AA190235 and I will be present our lab 4, which is electro-pneumatic and electro-hydraulic system. So let's start with the lab activity 1. So for lab activity 1, the question asks to develop the diagram figure 1 in fluid sim software. So this is the figure 1 where we need to develop the electro-pneumatic circuit and also the electro-hydraulic circuit. For electro-pneumatic circuit, we will use a single acting cylinder, three two-way solenoid spring return valve as a vis unit and also a compressed air supply. While in electro-hydraulic circuit, we need to have a single acting cylinder, three two-way solenoid spring return valve, tank, a pressure relief valve, and also a pump unit where the hydraulic fluid will be supplied from. So for both electro-pneumatic circuit and electro-hydraulic circuit, the electrical diagram will have the push button, a normally closed limit switch, a relay, a contact relay, and also the solenoid. So let's move to the fluids. So this is the electro-pneumatic circuit for our lab activity 1. So let's run the circuit. As we run the circuit, we can see that the pressure air is only being supplied to the valve and there is no compressed air into the cylinder. So we need to press the push button and we can see that when we press the push button, there is electric flow into the circuit. And when we press the push button, there will be a pressure air flow from the valve into the cylinder and extending the cylinder. The cylinder is extended. So let's move to the electro-hydraulic circuit. So this is the electro-hydraulic circuit. So let's run the circuit. When we run the circuit, we can see that just like the pneumatic circuit, the hydraulic fluid is only being transferred into the valve. It cannot be transmitted into the cylinder and extending the cylinder. So we need to press the push button. And as we press the push button, we can see that there is a electrical flow into the circuit. And when we press the push button, the cylinder is extended and retract. When we press the push button, the cylinder is being extended. For lab activity 2, we also need to develop the electro-pneumatic diagram based on the figure 2 in the fluid sim. So this is the electro-pneumatic diagram that we will need to develop. So the pneumatic diagram will have the double acting cylinder, the 5 two-way solenoid valve, air service unit, and also a compressed air supply. So for the electrical diagram, we will have a detent switch, relays, a normally closed and a normally open limit switch, a contact relay, and also a solenoid. So let's move to the fluid sim. So this is the circuit for our lab activity. So let's just run. So as we run the circuit, we can see that there is electrical flow into this part of the electrical diagram, and the compressed air are being transferred into the valve and retracting the cylinder. So when we press this detect switch or S1, when we press, we can see that the electrical flow is being transferred continuously into the circuit according to the condition of the 1B1 and 1B2 switch, either it is being closed or open. So at the same time, in the pneumatic diagram, the compressed air are being transferred into the valve and extending and retracting the cylinder continuously without stop. So to stop the circuit, we need to depress the S1. So that's it for lab activity 2. For lab activity 3, we also need to develop the electro-pneumatic diagram. So this is the electro-pneumatic diagram that we will need to develop, which is the pneumatic diagram will have a double acting cylinder, 5 two-way solenoid valve, air service unit, and also a compressed air supply. While in the electrical diagram, we'll have a detent switch, a contact counter, relay, a normally open magnet proximity switch, a magnet proximity switch, a relay contact. This is the relay contact, solenoid, counter, and also a push button. So let's move to the fluid sim. This is the electro-pneumatic diagram for our lab activity 3. So this is the electrical diagram and the one above is our pneumatic diagram. So let's run the circuit. When we run the circuit, we can see that the air pressure is being transferred into the air service unit, into the valve, and retracting the cylinder. While in the electrical diagram, there is a electrical flow into the 1B1 and 1B2 switch. So when we press S1, it will trigger the counter so the electric feeds into the circuit one by one in every level according to the condition of 1B1 and 1B2, either it is being open or closed. And the cycle will continuously repeat for 5 times as the counter will count for 5 times only. So at the same time, when we press the pressured air will be transferred into the valve and extending and retracting the cylinder for 5 times. As we can see, it will extend and retracting this. While when we press push button or S2, it will also repeat the same movement when we press push button S1. And the cycle also continue for 5 times because the counter is set for 5 times. So to reset the counter back to its initial count, we can depress the S1 and press S2. So here we can see that the counter is being reset. So that's all from me. Thank you.
Assalamualaikum and hi, my name is Sharifa Azila binti Ruslan. And for today, for this week, I will present about observation and question from lab activity 1 until lab activity 3. So let's proceed with observation lab activity 1. The question is, briefly discuss the function of the two components circled in red below. Okay, the first one is a hydraulic reservoir or tank, and the second one is compressed air. Okay, so the function of a hydraulic reservoir is a container for holding the fluid required to supply the system, including a reserve to cover any losses from minor leakage and evaporation. So function for compressed air is forcing air into a container and pressurizing it. Okay, so for the question number 1 is describe the difference between electro-pneumatic and electro-hydraulic system. Okay, electro-pneumatic system is confined pressurized system that use moving air or other gases, while electro-hydraulic system is confined pressurized system that use moving liquid. Electro-pneumatic system also lighter in weight and electro-hydraulic system heavier in weight. Okay, the question number 2, describe an industrial application for electro-pneumatic and electro-hydraulic system shown in figure 1. Okay, electro-pneumatic system industrial application is nail gun and drill, while for electro-hydraulic system, the application is hydraulic jack flip and forklift. Okay, so lab activity 2, observations for lab activity 2. Question number 1, state the name of component 1B1 and 1B2. 1B1 is actually normally closed and 1B2 is normally open. Okay, question number 2, briefly discuss the function of 1B1 and 1B2 in the circuit diagram. Okay, the function of normally closed and normally open is actually to detect any airflow through it. Normally closed means that compressed air cannot flow through the valve, while when the push button is activated, the valve is open, thus allowing the air. Okay, during question number 3, during simulation, a symbol with an arrow always appears next to the component in the electrical diagram. Describe what do you understand when you see the symbol. An error will appear when there's current flow in switch, but an error will um, error will disappear when there's no current flow on it. Okay, so for the question, discuss the importance of component A in actual industrial application. Component A is actually a service unit. So in a service unit, there is 3 parts in this component. The first one is filter. The function of filter is to remove impurities present in compressed air before it is delivered to pneumatic components. Okay, the second part is pressure regulator. The function of pressure regulator is allows us to regulate pressure manually. And the last part is lubricator, which is the function is to provide lubrication for pneumatic components. Okay, so observation for lab activity 3, tabulate the list of components used in figure 3. Okay, so for observation in the circuits, we can list some of the components that have been used for this circuit. Okay, for example, there is compressed air supply, air service unit, 5-stroke two-way valve, double acting cylinder, detent switch, valve solenoid, relay counter, and magnetic proximity switch. Okay, and explain the function of S2. Based on the experiment in simulation, function of S2 is to trigger C1, which is counter. And the last question is, the position of 1B1 and 1B2 in figure 3 is different from figure 2. By referring to component A and B below, are both types practical for 1B1 and 1B2 in figure 3? Explain your answer. Okay, so we have to know or component A, it is a limit switch or known as a limit switch. This limit switch as a lever that is used to close the contacts inside the switch. When the contact is closed, it also has a spring to help return the limit switch to its original position. And for component B is magnetic proximity switch. This switch is very useful for detecting objects that have a magnetic field. When this switch detects a magnetic field in an object, the contact will be closed and allow current to pass. Okay, so in a conclusion, for component A, this component is very suitable to be used on this circuit if there is no need to detect the magnetic field on the object. And component B is more suitable to be used for this circuit because this component is very suitable for use in this circuit to detect the magnetic field. Okay, that's all from me. Thank you.